Have you ever wondered what makes your electronic devices convert the alternating current from the wall into the stable direct current they need to function? There is a critical component that often seems like a simple afterthought, but its correct selection is absolutely vital for efficient and safe power conversion. It is the load resistance, and choosing it correctly in a rectifier circuit is more nuanced than it might appear. The choice of load resistance in a rectifier circuit is fundamentally determined by the desired output direct current voltage and current, as well as the rectifier's ripple and power dissipation limits. This selection directly impacts the performance and longevity of the entire power supply. At its core, the load resistance dictates the operating point of the rectifier. It essentially sets how much current will be drawn for a given output voltage. This, in turn, affects crucial parameters like the average direct current voltage across the load, the peak inverse voltage that the diodes must withstand, and the power dissipated by the diodes themselves. It is all about establishing a harmonious balance between the power source and what the load demands. So how do we make this choice practically? First, you need to clearly define the output requirements of your load. What specific direct current voltage does your device need, and what is its maximum current consumption? Once these are known, you can use a simple application of Ohm's law, where resistance equals voltage divided by current, to calculate a nominal load resistance value. Next, consider the power dissipation. Calculate the power the load will dissipate by multiplying the direct current voltage by the direct current, and ensure your chosen resistor can safely handle this power. If using a filter capacitor, remember that the load resistance, along with this capacitance, directly determines the ripple voltage. A larger load resistance or a larger capacitor will typically result in less ripple. Always ensure that the operating current and voltage levels, set by your load resistance, ranges well within the forward current and peak inverse voltage ratings of your rectifier diodes to prevent damage. An interesting consideration in rectifier design, especially with inductive capacitive filters, is the concept of a critical resistance. This is the minimum load resistance below which the filter's output current becomes discontinuous, leading to increased ripple and poor regulation. Understanding this allows engineers to optimize the filter's smoothing capabilities and overall efficiency. It highlights the intricate trade-off between achieving very low ripple and maintaining good output voltage regulation under varying load conditions. Ultimately, a thoughtful and deliberate selection of load resistance is for more than just connecting a component. It is about optimizing the rectifier's efficiency, protecting the individual components from stress, and ensuring a stable, clean direct current supply that allows your electronic devices to perform reliably and consistently. This careful engineering choice is foundational to robust power supply design.